Good morning, dear students. My name is Ferhan Mazher, and today is 13th November 2021. And the day is Saturday. Right now, I am with the ninth Cambridge class, and we are studying the DMaths 4024. We are working on the syllabus, and today we have selected an exercise from the D4. The book we are studying is New Syllabus Mathematics 7th edition. This we call D4 book and chapter number 5, and we are going to do the exercise 5D today. In this exercise, we are going to learn about the how to find the determinant of 2 by 2 matrices and inverse of 2 by 2 matrices. So let's start this exercise, and here we go. So exercise 5D, the question number 1, he says find the determinants and inverse of the given matrices where possible. So let's do this question number 1. Its first part 3, 4, 5, 6. That's the matrix. And let me show you how we will do that. Okay. So the question number 1 is coming up on your screen. Question number 1. If question number 1 and its first part, here you have that matrix A, 3, 4, 5, and 6. So first of all, if you want to find out the determinant, you see along this diagonal, you multiply these two numbers. So that will be 3 into 6, and then a negative, and you multiply these two numbers on this diagonal. So that will be 4 into 5. So it will be 18 minus 20, and that will be minus 2. So then I will find the adjoint of A. The adjoint of A, these two, the members along this diagonal, we change their place with each other. So 6 will come here and 3 will be here. So these two members on this diagonal, we change their sign. Simply we change their sign. It will become minus 4, it will become minus 5. So A inverse is equals to 1 by A determinant into adjoint of A. So it will be 1 divided by minus 2 into adjoint, that's 6 minus 4 minus 5, 3. So this minus 1 by 2, that's multiplying with this matrix. So it will multiply with every member of this matrix. So it will become 6, 1 by 2, minus 1 by 2 multiply 6, that will be minus 3. Minus 1 by 2 multiply minus 4, it will be minus 2. Minus 1 by 2 multiply with minus 5, it will be plus 5 by 2. And minus 1 by 2 multiply 3, it will be minus 3 by 2. So this is how you will find the determinant and inverse of this determinant. Okay, so question number 1 in the second part is that B. I just gave it the name B, that is 2 minus 1, 3, and minus 3 by 2. So I will find first of all its determinant. So the members along this diagonal, I will multiply them with each other. And you can see they're here 2 and multiply with minus 3 by 2. And then a negative, and then I will multiply these two members with each other along this diagonal. So 3 multiply with minus 1. So that will be equals to 2 and 2 cancel. You will have minus 3 here, minus plus. So you will have 3. Minus 3 plus 3, and that will be equal to 0. So the determinant of this matrix is 0. This is a singular matrix, so its inverse is not possible. Any matrix whose determinant is 0, you cannot find its inverse. So that was question number 1. Second part. Okay, so question number 1. Third part is showing up on your screen. Here the matrix C is given 3, 5, 1, 2. So first of all, I will find out the determinant. So that will be, I will multiply these two members along the diagonal, along this diagonal. So it will be 3 into 2 minus, and then I will multiply these two with each other. So 1 into 5. So you will have 6 minus 5, and that will be 1. So the determinant of this matrix is 1. Then I will find the adjoint of this matrix. So these two members, their place will be interchanged with each other. And these two members, their signs will be changed. So here you will have 2 minus 5 minus 1 and 3. C inverse is equals to, the formula is 1 by C determinant into adjoint C. So 1 divided by 1 into adjoint C is 2 minus 5 minus 1, 3. So you divide each number with this, you multiply with 1 by 1, so you get this final answer, 2 minus 5 minus 1 and 3. So this is how you will find the inverse determinant and the inverse of the matrix C. So that was the question number 1, 3 part. Okay, so let's go to the next part. So question number 1 and 4 part, here you have a matrix. I have named it D, 3, 10, 2, 7. So I will first of all find its determinant. For that purpose, I will multiply these two members along this diagonal. So 3 multiply 7 minus 2 multiply 10, and it will be 21 minus 20 and equals to 1. Adjoint of D, I will change the place of these two members along this diagonal, and these two members along this diagonal, their signs will be changed. So the adjoint of D will be 7 minus 10 minus 2, 3. Then I will find the inverse. The inverse will be 1 by D determinant into adjoint of D. So it will be 1 by 1. And the adjoint is 7 minus 10 minus 2 and 3. So you divide or multiply with 1 by 1. So you get the same matrix. So the D inverse is 7 minus 10 minus 2, 3. So this was question number 1 and its 4th part. Okay, so the 5th part. Here I have named it as E. E is equals to minus 8 minus 4. Minus 8 minus 4 minus 4 minus 2. So I will multiply these two members. So it will be minus 8 multiplied with minus 2 minus 4 multiplied with minus 4. So it will be plus 16. Here it will be minus 16. So 16 minus 16, that will be 0. So because the determinant is 0, so it's a singular matrix. So its inverse is not possible. So simply we will write that the inverse is not possible. Okay, so question number 1 and the 6th part, I have named it as F. So it's 1, 3, minus 2, and 6. So it's 1, 3, minus 2, and 6. So first of all, I will find the determinant. I will multiply these two members with each other, and then minus, and then I will multiply these two with each other. So you will have 6 plus 6, so that will be 12. So the determinant of this matrix is 12. So then I will find the adjoint of this matrix. So for the adjoint, I will change the place of these two members along this diagonal with each other. And these two members, their signs will be changed. So you will have 6 minus 3, 2, and 1. So the inverse, the formula for the inverse is 1 by F determinant into adjoint F. So we will have 1 by 12 into then that adjoint of F, that's 6 minus 3, 2, and 1. So 1 by 12 will 1 by 12 multiply with all these two. So you will have 6 by 12 minus 3 by 12, 2 by 12, 1 by 12. So you can cut them, you can cancel them. So you will have 1 by 2 minus 1 by 4, 1 by 6, 1 by 12. So this is how you will find the determinant and the inverse of this matrix. So that was the question number 1 and 7 part. Now we have question number 1. Sorry, that was question number 1 and 6 part. This one is question number 1 and 7 part. So here I have named it as the matrix G. So first of all, I will try to find out its determinant. So for that purpose, we will multiply these two terms with each other. So 1 into 1 minus, then these two terms with each other, 0 into 0. So it will be 1 minus 0, and that will be 1. Then I will find the adjoint G. The place of these two members will be interchanged with each other. And these two members, I will change their sign because this is 0, neither it is positive nor it's negative. So you cannot change their sign actually. So then I will write the formula G inverse is equal to 1 by G determinant into adjoint G. So 1 by 1 into 1, 0, 0, 1. So that will be 1, 0, 0, 1. So the inverse of G is 1, 0, 0, 1. Hopefully you understand this. Okay, so the question number 1 and this 8 part is showing up on your screen. H is minus 1, 3, 1, minus 3. So the H will be -1 into -3. I multiply these two with each other, then negative, then I will multiply these two with each other. So I will have -1 into -3, that will be +3 minus, and 1 into 3, that's 3. So 3 minus 3, that's 0. So because determinant is 0, it's a singular matrix. So if the matrix determinant is 0, you cannot find its inverse. So inverse is not possible. So that was the question number 1 and its 8th part. Okay, so the question number 2 is showing up on your screen, but before I solve it, let me go and check it from the book. Okay. So the question number 2 is showing up on your screen. So you can see that question 2. If the A is this and the B is this, find the AB and BA. Determine the relationship between A and B. So this is the question, and this is question number 2 from the exercise 5D. So let's try to solve this. Okay. So the question A is given, that's 2, 3, 5, 8. B is given, that's 8 minus 3 minus 5, 2. So the first question was find the value of the AB. AB means A multiply B. So I will put the matrix A, that's 2, 3, 5, 8, and I will multiply it with the matrix B, that's 8 minus 3 minus 5, 2. So how you multiply? It's very simple. From the first column, I take the row. And from the second column, I take the column. So first row first multiplies with the first column, then the first row multiplies with the second column. And I write them here and then here. Then I will take this second row and it will multiply this first column. I will write the answer here. I will multiply the first row, second row with the second column, and that answer will be written here. So it will be like 2 multiply 8 plus 3 multiply minus 5. And then it will multiply with the second, column. So 2 multiply minus 3 plus 3 multiply 2. And now there are no more columns. So the second row will start multiplying. The second row will multiply with the first column. Then the second row will multiply with the second column. So here we got 5 multiply 8 plus 8 multiply minus 5. And then you have 5 multiply with minus 3 and plus 8 multiply with the 2. So you will have 16 minus 15 and then minus 6 plus 6. And then you will have 40 minus 40. And then you will have minus 15 and plus 20. So that will be equals to, that will be equals to 1001. Okay. So that will be 1001, and that is the I, that is equals to the identity matrix. 1001 is called the identity matrix. Identity matrix. Okay. So then I will find out the BA. BA means the value of the matrix B multiplied with the matrix A. So you can see that here I have put the value of the matrix B, and then we have the matrix A. So I will multiply them. From here, I will take the first row, and that will multiply with the first column. And I will put the answers here. Then the first row will multiply with the second column here. So its answers will come here. Then we will have the second row and it will multiply with the first column. Its answer will come here. And then the second row will multiply with the second column and its answers will come here. So here you see, I'm going to multiply them. So you can see that 8 multiply 2 plus minus 3 multiply 5. And then you will have 8 multiply 3 plus minus 3 multiply 8. Then you will have the second row will multiply with the first column. It will be minus 5 multiply 2 plus 2 multiply 5. You see this first row is multiplying with the first column. So it will be, then it will multiply with the second column, and it will be minus 5 multiply 3 plus 2 multiply 8. So it will be 16 minus 15, 24 multiply 24, and minus 10 plus 10, and minus 15 plus 16. So you will have 1001, and that's the identity matrix. So you see, you multiply A with the B, you get identity matrix. Then you multiply B with the A, you get identity matrix. If this is the relationship between the two matrices, then they are definitely inverse of each other. So they both, A and B, are inverse of each other. So this is how you do question number 2. So let's go to the next question. Okay, so the next question is coming up on your screen, but I want you to read it from the book first. Question number 3 is, if P is equals to 7934 and the Q is equals to 4 minus 9 minus 3, 7, find PQ and QP. Determine the relationship between P and Q. Okay, so let me show you my answer. So here we go. First question is, what is the value of the PQ? So I will put the value of the P matrix and the Q matrix, then I will multiply them. From the first matrix, I will take the rows. From the second matrix, I will take the column. So 7 will multiply with 4. The 7 is going to multiply with 4 plus 9 multiply with minus 3. Then 7 will multiply with the minus 9 plus the 9 will multiply with the 7. Then you will have the second row is turned. So it will be 3 multiply 4 plus 4 multiply minus 3. Then you will have 3 multiply minus 9 plus 4 multiply 7. So you will have, finally, you will have 28 minus 27 minus 63 plus 63 and 12 minus 12 and minus 27 plus 8. So the answer will be 28 and the minus 27, that will be 1. Minus 63 plus 63, that will be 0. And 12 minus 12, that will be 0. So minus 27 plus 28, that will be 1. So it's identity matrix. So when you multiply P with the Q, the answer is 1, 0, 0, 1, which is identity matrix. So in the same way, I can find out the QP. Q means the value of the matrix Q, and then I will multiply it with the value of the matrix P. So you will have 4 minus 9 minus 3, 7, and 7, 9, 3, 4. So we multiply them. So you will have 4 into 7, that will be 28, minus 9 into 3, that will be minus 27. In the same way, when the first row will multiply with the second column, the answer you will get will be 4 into 9 plus minus 9 into 4. So it will be 36 minus 36. Then you will have the turn of the second row and it will multiply with the first column. So you will have minus 3 multiply 7 plus 7 multiply 3. So it will be like minus 21 plus 21. Then the second row will multiply with the second column. So you will have minus 3 into 9 plus 7 into 4. So it will be minus 27 plus 8. So 28 minus 27, that will be 1. 36 minus 36, that will be 0. And minus 21 plus 21, and that will be 0. Minus 27 plus 28, that will be 1. So this is how you will show that the P and the Q, they are, when you multiply them, their resultant is 1. So it means, if the two matrices, you multiply them with each other and the determinant and their multiplication is identity matrix, it means that both of them are inverse of each other. So this was the question number 3. Now we go to the next question. That's question number 4 coming up on your screen. So first of all, read it from the book. Question number 4 is coming up. He says, find the inverse of the following matrices where possible. So we have to find the inverse of the matrices. So let's start. The question number 1 is question number 1 is A is equals to, I just gave it its name, P, Q, R, and S. So first of all, I will find out the determinant, and you know that. Okay. So first of all, I will try to find out the Okay, so I will multiply these two terms with each other and minus these two terms. So you will have P multiply S minus R multiply Q, and that will be PS minus QR. Then I will find the adjoint of the determinant is I will change the place of these two with each other, and I will change their signs along the members along this diagonal. So you will have S minus Q divided by minus R into P. So I will find out the inverse, and the formula is 1 by A determinant into adjoint of A. So that will be 1 by, the determinant is this whole thing. So it will be PS minus QR downstairs. Then I will have the adjoint of A, that will be S minus Q minus R and P. So this is the question number 1 of the question 4. So now we are on the question number 4, and it's B part. Here a matrix is given. I have named it as B, so it will be A0, 0, 1 by 2A. So I will first of all find the determinant. These two members, they will multiply with each other. So when you multiply A with 1 by A, you get 1. When you multiply 0 with the 0, you get 0. So 1 minus 1, that will be 1. It means that determinant of this matrix is 1. Then I will find the adjoint of B. You know how to find the adjoint of B. Adjoint of B, sorry. We change the place of these two members with each other. And so 1 by A will come here, A will be here. So, and then we change the sign of the members along this diagonal. So because they are zeros, so they don't have any sign, positive, negative sign, I mean. And that's the adjoint of B. So that B inverse formula is 1 by B determinant into adjoint B, and that will be 1 by 1 into 1 by A 0, 0, 1. So it will be 1 by A 0, 0, A. So question number C is, here we have minus A, B, A, and B. So the determinant of this C will be, I will multiply these two with each other. So minus A multiply B, minus I will multiply these two members. Okay. So now you will have minus B, and that will be minus 2AB. Then I will find the adjoint of this matrix C. For adjoint, I will change the location of these 2 points. The B will come here and minus 1 will be here. And I will change the sign of these 2 members. Okay. So it will be B minus A minus A. So then I will find the C inverse. C inverse is 1 by C, and into adjoint C equals to 1 by, I will put these values, that will be 1 divided by minus 2AB into the adjoint C, that's B minus A minus A. So C inverse will be B divided by minus 2AB minus B divided by minus 2AB minus A divided by minus 2AB and minus A divided by minus 2AB. So you will have these B and P will be cancelled. So you will have minus 1 by 2A, then you will have B and B cancel. So you will have 1 by 2A, and then you will have A and A cancel, minus minus cancel. You will have 1 by 2B here, the A and A will be cancelled, minus and minus will be cancelled, so you will have 1 by 2B. So you see, this is how you will find the inverse of C. First we found the determinant of the C, then we found the inverse of the C. So that was question number 4, C part. Okay, so the question number 4 and its D part is showing up on your screen. So you have cos X minus sin X and sin X cos X. So here, first I will find the determinant. I will multiply these two with each other. So you will have cos X into cos X, then I have minus, and then I will multiply these two with each other. So you will have sin X into minus sin X. So here you are supposed to write a negative sign. I just forgot that. Okay, so let me write that. Here we have negative sign. Okay, so you will have cos square X plus sin square X, and this is, you have not studied it in O levels, but this is in 9 metric course, I mean 10 metric course, and you will study this in your A levels. This is an identity. Cos square X plus sin square X is equals to 1. Okay, so then I will find the adjoint of D. I will change the place of these two with each other, and I will change the sign of these two. So you will have cos X, sin X, minus sin X, cos X. So you know that D inverse will be 1 by D determinant into adjoint D, and that will be 1 by 1 into the adjoint D. That's cos x sin x minus sin x cos x. So you divide it with 1, multiply it with 1, so it will cause no effect. So the D inverse will be cos x sin x minus sin x cos x. Okay, now the question number 4, and its E part is showing up on your screen. The E part is 0, minus 1, 1, and 0. So E will be, first of all, I will find the E determinant. So I will multiply these two members with each other, and then minus, that's the minus in the formula. Then I will multiply these two members with each other. So you will have 0 into 0 minus 1 into minus 1. So you will have 0 plus 1, and that will be 1. So the determinant of this matrix is 1. So then I will find the adjoint of the matrix E. I will change the position of these two with each other. So, and I will change the sign of these two. So you will have 0, 1, minus 1, and 0. E inverse will be 1 by E determinant into adjoint of E. So it will be 1 by 1 into the adjoint of E is 0, 1, minus 1, and 1. So it will be 0, 1, minus 1, 1. So this is how you will do question number 4 and its E part. So now on your screen, the question number 4 and its F part is showing up. You will have 4, 0, 0, 1. So F is equals to, I will find the determinant. So I will multiply these two with each other. So it will be 4 into 1 minus 0 into 0. So it will be 4 minus 0 equals to 4. So then I will find the adjoint of F, and that will be, I will change the position of these two with each other, and I will change the sign of these two. So you will have 1, 0, 0, 4. So the F inverse is equals to 1 by the F determinant into adjoint of F. So you will have 1 by 4 into 1, 0, 0, 4. So this 1 by 4 will be multiplying with this whole matrix, with every member of that matrix. So you will have 1 by 4, 0 by 4, and 0 by 4, and 4 by 4. So you will have 1 by 4, and 0, and 0, and 1. So this is how you do question number 4. Now we have the question number 4 and its G part. He says the G matrix is equal to, I just gave it the name, G is equal to 0, 0, 1, 0, 0, 0, 1 by 3. So the G determinant will be, you will multiply these two members along this diagonal minus the two members along this diagonal. So you will have 0, 1 by 0 multiply 1 by 3 minus 0 multiply with the 0, and you will get 0 minus 0, and that will be 0. So that because the determinant is 0, so you cannot find the inverse of this matrix. Okay. So my dear students, today we have done exercise 5D, question number 1, question number 2, question number 3, and question number 4. And hopefully you have understood these questions. So thank you very much, everybody. It was a pleasure teaching you, and God bless you all. So thank you very much. Have a good day.